Today's lesson is on section 8.1, apply exponent properties involving products. In this chapter, we're going to learn a bunch of different, as I call them, shortcuts for ways we can simplify problems that have powers in them. And first I'm going to talk about, or remind us, well, what do powers mean, or what are these expressions, what do they do? These are called powers. Expressions like these, like in this case, one way we could say that is 4 squared. And if we're going to evaluate that, remember this means like 4 times 4, which in this case would be 16. This one over here, 5 to the third power is how we would say that. If I was going to write that as a product, it'd be, what does it mean? It's like 5 times 5 times 5, which is 125. So we've dealt with powers before. That's nothing new. So this is just a little bit of review on what powers are. Again, if you're taking notes along with me here in the red, I'd like you to write some of this down. A power is an expression that represents repeated multiplication of a factor. That's exactly what's happening up here. I've kind of blocked it off now, but repeated multiplication. So it says 5 to the third power. That means 5 times 5 times 5. And again, these numbers even, the big and small number, have names as well. The big number in the power we call the base. At least I'm just calling it the big number now, but the big number in the power we call that the base. The little number is the exponent. And so maybe if you want to make a little example, kind of like the ones I have up there, maybe something like 6 to the third power. Well, the base, again, the bigger number, that's the number that we're going to multiply by itself however many times. So in this case, 6 and the exponent 3 means we're going to multiply that number by itself 3 times. So 6 times itself 3 different times. And again, sometimes we'll just have to evaluate that. Sometimes we can write it as a product. And that's kind of like, what does it mean? Well, 6 times 6 times 6. We'll just look at the directions and look at what they're asking us to do, and if there was problems like that. So in the past, if I've had a problem with exponents in it, well, what I've done is just, the directions might say evaluate. So I'm just looking to find that value, find the answer. I might just evaluate. And that means I'm going to try to find some answer for this problem. So if it says 3 to the third plus 5 squared, I could punch those in my calculator, or I'm just going to kind of break it apart here and then again show us a shortcut or a way we can simplify using exponents or using it with powers. But this means, again, 3 times 3 times 3. 3 to the third means 3 times 3 times 3. And then plus I've got, well, and 5 squared means 5 times 5. So in the past, if I've had a problem like this, I would just have to evaluate, just like I'm doing now. 3 times 3 times 3 would be 27, plus 5 times 5, which would be 25, and I could figure out the answer's 52. Same thing in the next one. 2 to the fourth power would just be 2 times 2 times 2 times 2. And then it says I got to multiply that by 3 squared, which would be 3 times 3. And I could figure out the answer to that problem. Problems like this, again, in the past, maybe we just evaluate it. But there are certain powers and certain rules that allow us to simplify some powers and just rewrite them still as as opposed to having a bunch of different powers multiplied together. Well, there's a simpler way. Sometimes I can combine them or kind of simplify it as the directions say. So I just have one power to write. And again, maybe it sounds a little confusing right away, but I think you'll see it's not too bad with an example here I'm going to show. This example right here, think about the ones we just did up above. If I was going to evaluate those powers, I wrote them out kind of as a product, and that's what it would mean. Well, looking at this problem right here, this says 3 to the third times 3 squared. Well, again, what's 3 to the third? That would be 3 times 3 times 3. And this then says multiply. Well, I want to multiply that times 3 squared, so I guess that'd be 2 more 3's. Since we're multiplying the same base for these powers, since both the bases are 3, this is a little shortcut we can use to simplify this problem and not have to necessarily find that exact answer, but just to rewrite it as a simpler power and just a single power. 3 to the third times 3 squared. Well, that's like having 5 different 3's multiplied together, correct? So really I could write this. This is really the same thing, and I'll usually ask students in class, and somebody will be able to kind of figure that out, that it's just like 3 to the fifth power. So when you see a problem like this, and the directions might say simplify or write as a single power, 3 to the third times 3 squared is just 3 to the 5th power. So this is our first rule. Again, we'll learn a bunch of different rules in this chapter, but this is the first one. And if you're taking notes along with me again, here's what I'd like you to write down. The product of powers rule. And again, don't be too worried about those words. It's just like the words are telling you. It's the product of powers. When I multiply powers together, here's a rule. Here's a way I can simplify that problem. Well, if I have things, and it's kind of the key is here, you notice m to the a times m to the b, kind of the algebra version, but just notice that it's the same base. If we're talking about the same base number, and I'm multiplying powers together, what can I do with a and b? Well, it says you can just add those together, and you'll keep that same base, but it's like that number to whatever power that combining the two powers together. So for example, number 1 here, again, breaking it apart kind of like I did with the previous example. 4 to the 6, what would that mean? Well, that would mean 4 times itself 6 different times. And then this says multiply, I'm still multiplying, times 4 squared. Well, that's just 4 times 4. So if I'm multiplying all those together, well, what I got here, well, this is the same as 8 different 4s multiplied together, so it's just 4 to the 8th power. So you could just say 4 to the 6th times 4 squared equals 4 to the 8th. That's a way to simplify this and write our answer using exponents or as another power, as a single power. Okay. This one, a little bigger numbers, but now just applying the rule. Again, I don't have to write it out as a product like I did here every time. I'm just kind of showing you that so you understand how the rule works or why we're able to do that. 15 to the 14th times 15 to the 26th. Well, again, this would be 14 different 15s multiplied together. And this would be 26 more 15s multiplied together. So how many total 15s would I have multiplied together there? I'd have 40 different 15s multiplied together. All it is adding the two exponents. 14 and 26 gives me 40. So 15 to the 40th power. This next one, r to the 12th times r to the 9th, just showing that it works with variables as well. Whatever the base is, as long as we have the same base when we're multiplying these together, then we can do this. R to the 12th, that'd be like 12 r's multiplied together. And then r to the 9th would be 9 more. So if they're all multiplied together, that's just like r to the 21st. I add 12 and 9 and get 21. Showing just a few more examples here about this rule. 4, 5, and 6. If you have a negative number that's a base, so like in this case I have negative 9 to the 3rd power, and again, negative 9 to the 5th power. If a negative number is my base, notice how it's in parentheses. That is important. So if you plug it into your calculator, if you ever have a negative number plugged into your calculator, you do need to have it in parentheses. So if it's negative 9 to the 10th power, it doesn't matter what power it is important though in your calculator to put it around parentheses, otherwise it may not evaluate it correctly. You might not get the right answers because every calculator does it a little differently. So even on these answers too, if our base is negative 9, like that, we're going to keep it in parentheses as well and still just apply the rule. So negative 9 to the 3rd times negative 9 to 5th. If I add 3 and 5, I get to the 8th power. So negative 9 to the 8th power. Same thing with number 5. It's a negative number as the base. So I got to keep that as negative 4 in parentheses in my answer as well when I simplify this. And in this case, even with a negative number in the exponent, we can still apply this same rule. 2 plus negative 5. Well, that's okay, and we'll learn how to deal with negative exponents very, very soon as well. But we can still write this as negative 4 to the negative 3 power. 2 plus negative 5 gives me negative 3, so that's what I get. Negative 4 to the negative 3rd power. And then this last one here at the bottom, x to the 7th times x to the negative 2nd power times another x. Well, this one also, we can still apply this rule. All 3 of these x's are multiplied together, and they have powers associated with them. So x to the 7th, x to the negative 2nd, and even this last one, even when there's no number for the exponent, really there's a number there, right? It's just implied. It's like up to the 1st power. There is one factor of x there. So I can still think about adding 7 plus negative 2 plus 1. And so in this case, that'll give me 6. So x to the 6th power. I'm going to teach us one more rule as well today. And this one deals with when we have a power to a power, as this directions are talking about here. When I have a power to a power, what does that mean? Well, here I have the base 3 to this exponent 2, right? And then all that's in parentheses, and then it's to another exponent, to the 4th power. So it's 3 squared, that expression, and then that to the 4th power. So a power to a power. 3 to the 2nd power, and then to the 4th power also. Well, this one, let's try to break this one apart, kind of like we did with some of the previous problems. So I'm going to write this like, what does that mean? If it was 3 squared to the 4th, well, this, whatever that is in the parentheses to the 4th, that means I'd multiply that times itself 4 different times, correct? So this would mean 3 squared times 3 squared times 3 squared times 3 squared. So I multiply that expression, that power, 3 squared, times itself 4 different times. Well, each little 3 squared can be broken apart as well. This is just 3 times 3. And then so is the next one, 3 times 3. And then so is the next one, 3 times 3. And then so is the next one, 3 times 3. So really, what ends up happening here, well, all I end up getting is that I get 8 different 3's multiplied together. So I could say that's like 3 to the 8th power. So now what I'll usually do is I'll ask students in class here, can they make the connection? Can you see what happens? Or what's this new? I'm going to learn a new rule here on this page. If I have 3 squared to the 4th power, can you make the connection? How can I jump right to the answer here and say that's 3 to the 8th? There's a shortcut, as I call it, or a rule that says we can simplify it just by doing one thing. You don't have to write it out like I did, but I'm just kind of showing you how it works or why it works. But if I have 3 squared to the 4th power, I'm telling you the answer to that is 3 to the 8th. So what's the rule that works? Well, in this case, if you have a power to a power, as students will start to realize, I can just multiply these two powers together. 2 times 4 gives me 8. So that's how I get my 3 to the 8th power. I'll show it again with this next one. So again, breaking it apart and showing you why it works. 5 to the 5th squared. Well, 5 to the 5th would be like, or 5 to the 5th squared would be like 5 to the 5th times itself. So 5 to the 5th twice. Well, if I broke that apart, this would be 5 times itself 5 different times. So that'd be the first one. And then multiply that by 5 times itself 5 more times. And so what does that mean? Well, that's just like 5 to the 10th power. It's like 5 times itself 10 different times. Well, again, can you make the connection? So if this is my problem, how do I get right to my answer? All I have to do is multiply the two exponents together and keep that same base. 5 times 2 gives me 10, so 5 to the 10th power in this case. Looking at this next one with a variable, one more time breaking it apart. So if it's y squared to the 3rd, I could say, well, this is just like y squared times y squared times y squared. Well, and that's just like having y times y times y times y times y times y one more time. So that's y to the 6th. So making the connection, you can just jump from this to the end result. It's just by multiplying the two powers together. So that's the other rule I'm going to teach you in this lesson. A power to a power rule, exactly like we're looking at. When I have some base to the 2nd power and then to the 3rd power, no matter what those powers are, what I can do is I can just take those two powers and, like it's saying here, I can just multiply them together, a times b. This is another, again, shortcut or rule or just a way to simplify problems with powers. So this one I wouldn't want to break apart. This one we're just going to apply the rule. 3 to the 10th to the 13th power. I don't want to write all those different ones out. All those 3's to however many different times I have to write it out. But we just know the rule now. If it's a power to a power, I can just multiply these two together. And I can just say, well, this is like 3 to the 130th power. And that's all I have to do is simplify that problem and write my answer using an exponent. Just showing you a few others we might see here. This one has parentheses and brackets. Remember, though, the parentheses, kind of like the ones we've seen earlier, are just noting that this is a -2. So again, and that's my base. So when it's a negative number for a base, they put in parentheses. And then the brackets are just showing, well, that power is also to the 4th power. So -2 is still my base. And I'm going to keep that in parentheses. But then my two powers are 6 and 4. So it's -2 to the 6th power, and then that to the 4th power. So again, here's where I'd just multiply those both together. And it's just -2 to the 24th power. Again, a bracket is just another type of parentheses, so that's just how they're showing that there. Just going through two other examples here. This one, again, just showing that it does work with a variable too. If I have t to the 8th power and then to the 4th, I can just multiply 8 and 4 together and get t to the 32nd power. And this last one I showed because this is something we're going to see later this year. And in intermediate algebra, we'll see this. And so it's something we'll learn to deal with another way as well. But if you have something where there's an expression here inside parentheses, like x plus 2, and that's the 5th power, and that's the 8th power, that x plus 2 can just be the base. Even though it's an expression, it's in parentheses, I can keep that as the base as well. So x plus 2, that's my base. And 5 times 8 gives me 40, so it's to the 40th power. So in this first part of section 8.1 here, the two rules I've showed us so far. So when I have a product of powers, again, something like 3 squared times 3 to the 5th can give me 3 to the 7th. I just add the two exponents like the rule says. Or if I have a power to a power, like 7 squared and that to the 4th power, it's just like 7 to the 8th. That's the two ways we can simplify power problems if we have the same base. In the first one, or just if I have a power to a power. Ways I can simplify exponent problems.